Cramming session, night before AB Calculus exam. This is my tip for those who are about to take the AP Calculus AB exam. This presentation consists of an overview of the stuff that you must need to know cold, along with my dad's notes on calculus. Shortly after, we will go over limits and slope fields, because they were the things that I had hard time while studying for the exam. After that, I will note some extra tips and reminders that I would suggest to future test takers. We will now begin with all the things you must need to know cold for AP Calculus. To start off, you must know your fundamental theorem of calculus. Just because it was introduced in the beginning doesn't mean it should be forgotten. This is helpful for free response questions. Next is the Rolle's theorem. This comes out a lot in multiple choice, with questions that ask for Roman numeral bullet points and the things that must be true. They throw this out at you, usually to create confusion. Know these theorems, then those seemingly hard questions become 3-pointers. Other theorems that likes to come out easily on multiple choice questions are MVT and IVT. Know some key wordings of the theorem, such as differentiable on the curve or continuous, and the theorem's diagrams. If you understand this concept, it's easier to remember. We will now move on to basic derivatives. Memorize these and make sure you can spit them out really quick. Most of these questions are 3-pointers. Some odd ones that are easy to forget are these, and these. Here are some more tricks that you can memorize to take the derivative quicker. You can go ahead and take the derivative of something to the traditional way, but with these, you can solve the problems quicker. But I highly recommend that you should be able to do them like second nature, or else you can easily make mistakes. Also, here are things that you must know when you're dealing with applications derivatives, or when you're dealing with graphs of derivatives. Remember, derivative means slope, and slope shows rate. One important thing that I consistently mess up is the chain rule, especially when you do derivative shortcuts. For example, if you take the derivative of an integrand, the easy way to remember is by plugging in the upper limit into the variable, and that'll be it. This is the example. You would think that the answer to this question is root 4 plus 9x squared, but in reality you are missing a step. You need to plug it in and do the chain rule. The 3 would then pop out, so the real answer to this example would be root 12 plus 27x squared. Chain rule shows up to trick you, but don't be fooled. For integration by parts, I recommend that you just master the tabular integration, especially if you can't tell if something is going to take multiple steps or not. Tabular integration begins by forming 3-column chart. You have a sine column, u column, and a dv column. The first column, you alternate signs, always beginning with a plus sign. You take the derivative of the second column and integrate the third. To find out your u, use the limit rule, or pick the one that is more complex. Here are more integration tricks if you want to speed up your calculation. For the application of integration, know the average value theorem. If you manipulate it around, you can find both the average rate of something or the average amount of something in a given time, depending on what the question gives you. Volumes are the most common, along with finding the area under the curve, and so on. They say that you just need to know the disk method, but that's a lie. Know them all. In multiple choices, sometimes some volumes are expressed as shell method anyway. And finding a non-rotational volume always comes out if you're given a free response question that deals with volumes. Just memorize it. Next, converting the radian to degree to whatever is important too. And if you don't want to memorize this hideous chart, then I suggest this method. First, draw a graph, then draw 3 lines. Do a bracket thing and divide each bracket with a comma. On the left side, write 3, 2, 1 like shown. Divide each value with 2, add some roots, then voila! You got sine values. By now, you should know that the other way around is cosine. Pythagorean theorem is useful especially when you're integrating stuff. Normally, you can't integrate a tangent, so the question people will throw in a 1 plus tangent squared to freak you out. But by using the theorem, you can convert that to secant squared, and integration of secant squared, tangent plus c, and so forth. Knowing what is odd and even can also help you out immensely, not only for trig graphs, but graphs in general. These are some more trick stuff, but you can still survive without knowing these. Approximation might be our least favorite topic, but some do come out, especially in the free response section. For trapezoidal rule, if you can't memorize it, then just draw the normal area of a trapezoid thing. And the free response people gives you credit, even though you don't really write out this ugly equation. Overall, just drawing out the graph in divisions will help you be able to create the equation without doing all this delta x and x1 and blah blah blah. The Euler's method is a piece of cake if you can draw the chart. It rarely comes out, so don't freak out too much. Same goes for Newton's method. They do come out, but rarely. Finally, we are done with the that you need to know cold material. Now we'll move on to limits. Just remember that in order for things to be continuous, it must have the same value when approached from both sides. In order for things to be differentiable, the slope must be consistent when approached from both sides. Remember, if it is differentiable, it is continuous, but not vice versa. When you're given the equation, then take these steps shown above to find your values. According to the notes, it says that plug in the approaching number into x, if it is not in 0 over 0, or infinity over infinity, or infinity minus 0 format. If it is 0 over 0 after you plug in for x, then simplify, either rationalizing the equation or just plain simplify. Remove the factor that makes the denominator a 0, then plug it in for x again. If it turns out to be infinity over infinity, then the coefficient of the value with the highest power is the answer. You can also get the value by algebraic manipulation. If it comes out to be infinity minus infinity form, then manipulate the equation into infinity over infinity and go from there. Also, if you plug in the value and comes out to be 0 over 0 format or infinity over infinity format, then you can always use L'Hopital's rule to find out your answer. Here are a few things to keep in mind. You can memorize this stuff if you feel like it, again, for the purpose of solving things faster. Slope fields, my best friend. In order to tackle this, you can first plug in the 0 for x and y. Look out for asymptotes and symmetry. If you still have no clue how it looks like, then just make the chart. That is the safest way. If you notice, some slope fields follow a general pattern. You can sort of memorize the pattern, and maybe you don't need to go through plugging in value stuff. One thing to be careful of it is to find out what the slope field is representing. Take for example this equation. You might look at the slope field and think, oh, it must be a parabolic equation or some sort. That is true for the original equation, but most often than not, the question is going to throw out dy dx equations. You can tackle these by finding the original equation by simply integrating it. If you integrate the x, it comes out to be something like a parabolic equation. You can confirm the answer this way. I don't recommend this method if you take forever when integrating something. These are some basic algebra stuff you can do to help you simplify, but these should be second nature by now. Finally, I would like to end this presentation by giving you my post-calculus tips. I thought of these tips after I took the actual exam. Okay, for the multiple choice section, these are you should have in mind. For one thing, any AP test gives you the time breakdown at the back of the test booklet. Keep this in mind when you take the test. It's important that you pace yourself. Next, if you're unsure of a question, just skip it. It's better than being penalized for a wrong answer. Check over your answers, especially if you have some time left. Calculate your approximate score and see if you should guess more answers or just leave some blank. By now, you should know if you got certain questions correct or not, unless you didn't practice enough. The equation to find out your approximate score is shown below. Pacing and wise decision are absolute for any types of test. For free response, once again, pace yourself appropriately. Be also neat in your answers, but at the same time, don't be a neat freak and waste all your time. Each letter has its own box. I really wish I knew this earlier because I remember solving out all my answers and then try to transfer the answers into the A section. Well, just know that you have plenty of space to show your work, so don't freak out. Be able to use the calculator pretty well. It's not good to be totally dependent on your calculator all the time, like doing simple math or integrating all the time with a calculator. But knowing how to do some techniques such as integrating on your calculator, it's very beneficial. And it can make your life way easier. Remember, for free response, you can return back to part A if you're finished with part B. It's a good thing, but don't really rely on it because you might run out of time either way. Know that there are 5 major types of FRQs out there, so practice and be able to categorize them when you're prepping for the free response section. Thank you for watching. Good luck on your calculus exams, everyone.